How do you manage complex routing in microservices environments? Imagine trying to direct traffic in a busy city where roads constantly change and new routes open all the time. Managing routing in microservices is just like that. It involves making sure each request finds its way smoothly to the right service without causing traffic jams or dead ends. When you work with many small services, each handling a specific task, routing becomes a puzzle you need to solve carefully. The goal is to keep everything running smoothly, even as services scale up or down or move around. One way to simplify this puzzle is by using an API gateway. Think of it as a traffic controller at the city entrance. It takes all client requests and decides where they should go based on the request path or method. This way, clients only see one endpoint, and the gateway handles the complexity behind the scenes. It also manages cross-cutting concerns like security and logging in one place, making your backend easier to handle. Since microservices often run on different servers or containers, hard-coding addresses is not practical. Instead, you can use service discovery. This is like having a directory that services register themselves with when they start. When another service or the API gateway needs to find a service, it looks up the registry. This makes routing dynamic, so requests always go to healthy, available instances. It also helps with load balancing, so no single service gets overwhelmed. Routing decisions also need to consider how busy each service is. Load balancing distributes requests evenly across multiple instances, preventing overloads. Health checks are vital here. Services expose health endpoints that are monitored regularly. If an instance is not responding or is slow, the system stops routing requests there. This keeps the system resilient and responsive. Sometimes, a client request needs data from multiple services. Instead of making the client do all the work, an aggregator service or the API gateway can handle this. It routes internal requests to each service, gathers the data, and combines it into one response. This reduces network traffic and makes the client experience smoother. To avoid failures spreading through the system, you can use circuit breaker patterns. If a service is slow or down, the circuit breaker detects this and stops requests from going there temporarily. This prevents system overloads and allows the service time to recover. Failover mechanisms can reroute requests to backup services or provide default responses if needed. In more complex setups, a service mesh can be used. Think of it as an intelligent traffic system that manages how services talk to each other. It handles routing, retries, timeouts, and security policies without involving the core business logic. It can route traffic based on rules like versioning or A/B testing, giving you fine control over how your services communicate. Finally, keeping track of how requests flow through your system is essential. Distributed tracing tags each request with a unique ID that travels across services. This helps you see where delays happen, which routes are used most often, and where failures occur. Tools like Kubernetes help with service discovery and scaling. API gateways such as Kong or AWS API Gateway manage routing and security. Service meshes like Istio or Linkerd handle service-to-service communication. Combining these tools with health checks and circuit breakers makes managing complex routing more straightforward and reliable. By using these strategies and tools together, you can keep your microservices environment organized, scalable, and easy to maintain. Routing becomes less of a headache and more of a well-oiled process that keeps your backend running smoothly.